This is Harini. Welcome back to our YouTube channel Code with Harini. Today we are going to solve the Leetcode July challenge, day 3. So let's look into this question. Find the kth character in string game. Okay. So what they're telling, Alice and Bob are playing a game. Initially, Alice has a string word A. Always he will have a word A, and they are giving you a character K. Now Bob will ask us to perform some operation for a var, generating a new string by changing a character to the next character in the English alphabet. For example, A, if A means, then he wants us to find and create the next character A, B. So like that we have to keep on find it, and we have to return, if you look into that, we have to return the B value. Okay, that's what we have, we have to return the kth character in a string. Okay, so that's what. So here if it is ZB, then we have to, what is next to Z? A. What is next to B? C. So we have to append ZB plus ZBAC. I hope this makes clear to you guys. Now the same way, here they have given a word A. Always the word will be A, no matter what. So A, then for A next to AB, then we have given AB. Then when AB comes, for A the next word is B, for B next word is C. Append AB plus BC. So when next word is AB, BC, for A next word is B, for B next word is C, again B next word is C, C is D. So this is the 8. So now when it 8 comes, you know we wanted to return k equals to 5. We don't need to compute further. You just return the k equals to 5th character on 0 based index. 5th means 0, 1, 2, 3, 4. We will return B. So now let's look into the solution. Okay, now as we know, let's take the same example. K equals to 5, right? Okay, now A, given A, for A what we have generated AB. For given AB, next character is B, next character is C, so AB. So what we have to do here is we have to do addition of these characters, then AB, BC. Next, for A next character is B, for B next character is C, C, and D, for C next character is D. So we have to append this, and AB, BC, BC, CD. So now if you look into the answer, it is 2 power 0. This is 2 power 1. This is 2 power 2. This is 2 power 3. So basically it is keep on increasing by 2 multiply, so doubles the given string. For example, AB, AB, BC, 2, 4. For now 4 we are getting 8. Next for 8 we will be getting 16. So this is how it works. Okay, let's look into the brute force solution. Let's assume the previous string. Previous string is nothing but A. Okay, because we have to have some string. With that we will be generating everything, right? So we assume then we will be traversing each character in that string and appending it to the current string. Okay, current string. Okay, first let's figure out the next character. What is the next character? So next character will be, we will be calculating ASCII value of A plus current character ASCII value, that you have to subtract it from the A to get at what position. For example, let's take the ch equals to c and a equals to 76 as the value. So here OOD of c wait, I will tell you, minus OOD of a plus 1, then on top this we will be modulo 26. I'll explain how this all works. So here if we have taken c, then OOD of c will come 79. 79 to get at what index exactly? 0 1 2, let's assume 0 1 2 3. So here if 76 starts, here if 77 78 79, so D will be 78, right? A B C. So that's what 78 minus 76 will be giving you 2. So to generate a next character we will be doing plus 1. So modulo of 26 will give you again 3. But when it goes to Z, so Z plus A will be 26 plus 1 equals to 27. So mod of 26 we have to do, so that we will be getting A. So that's why we are doing this. I hope this makes sense how this formula works. So the next character we will be keep on appending to the current string plus or equals to next character. So generate whenever you are also we have to run the loop length of the previous string less than k. So we will be basically running this. So from this we will be getting the character. There is no need of running all the keys. So that's the reason. So length of the previous string less than k we will be running. Every time you will be setting the current string equals to empty when you are going to the next, so that you can add. So current string, then when you are coming to the previous string what you have plus whatever we have generated the current string. That's it. Like this we will be generating. So what could be the possibility? So length of previous string less than k means it can run to the loop. For example, let's assume these powers are the t's. So time complexity will be t, and each t will be going to each of the string, so which is nothing but 2 power 0 plus 2 power 1 plus 2 power 2 until 2 power t, hopefully. So t star 2 power t assume will take. So this will be the time complexity. So to reduce this time complexity, what we are going to do? So if you look into the example, let's again take the same example. So it will be C C D A B B C C B C C D. Okay, so let's take this example. Also this is a given string, right? At the final output, when the k previous length of the string less than will go greater than k equals to here 5. So let's assume this is a 0 base index, right? 5 means we have to take 4. So 4, what all this? 2 4 8, length again above a equals to 1. So now we have got of length already a. So now what we have to do? Subtract minus 4 from this. 4 minus 4, it is going to 0. Correct. So from this a, this b got generated. Obviously you know, right? From this a only this b got generated. So that like this. So let's assume k equals to, now I'll just remove this. So A, B, C, C. Now assume k equals to 6. So k equals to 5, we know. B2 A element. So basically it is 4 to 0. So when k equals to 6, which means 5. How come 5 minus 4? 5 minus 4 is 1. From 1 minus 5 minus 4 minus 2, which is going less, but it means when it crosses this length, obviously we know another A was there, because that A we didn't add append. So initial A we won't append, right? So that you assume like that exists. So minus 2 is going here, which is also A only. But here if you see it went into twice. So 6 C2 D B2 A. So what all the 5 to 1 to 0. Let's assume like this. So what we are doing, basically whatever the previous powers, previous length of the string would be the responsive. Okay, sorry. What are the previous length of the strings would be responsible to contribute the next length. So obviously you know, if you from this position, if you minus that position, you know which contributes to this, correct? So because from this B only, when you are changing this characters A, B, so from this B only, so basically it is nothing but 4 plus that particular index position, right? So whatever the given value that k they have given, you just do reverse traversal of if something for example, this is 2 to the power of 3, this is 2 to the power of 2, 2 to the power of 1. So this length will be whatever the total k, 2 to the power of let's assume we will get the bit length of how many bits that corresponds to. So 8421. So to generate a length of 7, what will be the bit length to the max? It will be 3, right? Yeah, so like this it is also, if you take this is 2 power 0, 2 power 1, 2 power 2, 2 to the power of 3. So this is nothing but this is the same here as well. If you look into this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So if you take whatever the k value, for example here let's assume they have asked you the k equals to 5. What all for k equals to 5? Once again, I'll just so for k equals to 5, what will be your bit length? Will be setting 1 1, right? 0 0. So this will be your bit length till about. So also if you see to the max, it can go 3. So bit length is 3. So that's what k dot bit length. But we have to traverse from previous bits. So we are doing minus 1. So this is what we will be assuming the power from where it has to be start. So then we got the bit length. Okay. So what we are going to do? We know bit length is going to be 3 minus 1, which is 2. So then we will be doing 2 to the power of 2 we will be checking 2 to the power of 2, where now I have told you reverse traversal. Now we will be going from the forward traversal. So from here, okay, I know the bit length is plus 4. What will be my from A, if wait, let me tell you. So what we will be doing, okay, so now we know the power is 2, right? Because that's how we will, I know why we have chosen the power of, I have just explained, because this is of length 8, and to generate the length 10 we would have generated from the length of 4. So we will be, from any character we will be traversing back the length of the previous string, then we will know from which string it got generated. Okay, that is the reason. So here the same way, that's why we have deducted the -1 from the bit length. Bit length is nothing but for this k, how many to get this power, basically it is have 8 string. So now they have given k equals to 5. So now if I set this bit, I know how many power, in which power I am getting this particular k, right? So that's why we are setting the bit length, and we will be calculating, and I told why we are doing -1, right? So now we will be keep on, it's all to the power of t. Now if you know to the power of t, just subtract it from that. So already k equals to 5. 5 minus 4, k equals to 1. Add to the max, it can come to the 1, because here we are not taking 0 base units. So 1 means here it is 0. So from here only it could have done. So from A, this A only, this B, this B got generated, because k equals to 5 is here in this A. From this only you also know, na? From A, by manually also you can see, from this A only this B got generated. So that's it. So until k not equals to 1, this will be keep on running. We will be keep on finding out the bit length, and we will be checking out the power, previous power, and we will be minusing 1 while k not equals to 1. So in that we will be keep on adding the how many transitions happen. So here C, for this C we have only one transition, for k equals to 5 means B, right? For this B only one transition happened, it went to 0, which is nothing but k equals to 1. So yeah, you just append it to the count. Now you know from A plus 1, that is B. So this is the character. You can easily add it by the count. Another thing that we have to look into is, let's assume they are giving k equals to 8. So bit length will be the same. Okay, k equals to 8, which means 7. So bit length is same 3, k equals to 8. So if you see k dot bit length, so k minus k equals to already 8, minus 2 to the power of k equals to this is the bit length, right? So 4 minus 3 is, so 4 minus 3 will come in this power section. So now 2 power 3 is 8. So now 8 minus 8 will become 0. So that is wrong. So when it is the exact end of the character, so we should not take the, because it will go since the index will be from 0 to 7, it will crosses the 7 and it will go to the next. So you should not minus, we should always from even here, from we should first minus to 4. So from this C only this key would have come. So we should again, if that is a dead case condition, if 2 to the power of whatever the power equals to k, just 2 power minus or equals to 1, this condition that we will be appending. Why I am just appending this condition, I am just explaining. The same answer will be equals to the same. So from, if you look into this solution now, I'll just, for that 8th case I will be just explaining here. So from this 8 it will be minus 4, it will go here, from here it will go here. So I see minus 2, right? From this C minus 4, from here minus 2, this C would have got here, from this we will write minus 1. So like this. So D, how much translation it have taken? So A to B, B to C, C to D. So the count will be coming 3. So odd of A plus 3 is CH odd of A plus 3 is nothing but the ASCII value plus 3 we are doing. So we will be getting the exact answer B. So now we are just as per this explanation, I hope this you guys would have understood how come this bit length works and bit length and power works. So by this we are just traversing. For example, if they have given k equals to 3, we are just traversing 3. If k equals to 3, obviously it will come less than 4, right? So 2 to the power of whatever the t, so 2 to the power of 2 to the power of 2, 4, okay. Then my which we will not do, it is less than 2 to the power of 2, so we will be just doing straight away 3 minus 2, then 2 minus 1. So whatever the given power, whatever the k value exits previous power and this power, it will be lies here, and we will be subtracting the log of 2 to the power of t, 2 to the power of t minus 1. We will be keep on separating. So basically it will not even traverse to the value 5. So it's basically a log of k will be your time complexity for this. So basically if you look into any example, okay, whatever the bit that got set, okay, let's assume for D, for k equals to 8, bit length will vary from 0, 1 to 7, right? So for what will be your 1, 1, 1? This is nothing but the number of transition that we would have done. So here if you see in this 4 we have set 1, and after before 4 we have in this. So if you take into this example itself, you can see let's assume I'll tell you. A, B, B, C, B, C, C, D. Okay. So we will be calculating how come this bit count will work in this case. So just A plus whatever your bit count will be your resultant string, because So bit count equals to k equals to 7 in this case, right? So which 7 means, so 7 you will be traversing -4, which is this bit. So again you will be traversing to -2, which is this bit. So -1. So these are the bits that got set. So now if you see in this 4th index we have got 1 bit set. In the second 2 index we have got 1 bit set. So in this one we have got 1 bit set. So like this only, if you take any character like this only it will generate. For example, if you are taking character of 6, okay, so k equal to 6, in that case what will be our bit count? So k equals to 6. k equal to 6, our bit count will be 2, right? So our answer will be a plus 2 is C. So how that works? So bit count 6 means this is the 7th character. Sorry, bit k equal to 6 means, that means 5th character, right? Sorry, my bad. So see, this is the 5th character. How this comes? So in this 4 bit we are setting 1. Again if you see -4, because it crosses, it is going into, it crosses 5th now, it crosses 2 power 2. So obviously you should come minus, it starts with -4. So here if you see, this B came from this B, nothing but comes from this. Manually also we know this B comes from this A only. So you see, in this 2 bit we have set 1, and in this 4 bit we have set 1. So with this 2, whatever it is, you can straight away whatever the bit count, whichever the set bits were there in 8, 4, 2, 1 or 16 or 32, whatever it is, how many bits got set in that will be, if you append it to A, that will be your resultant string. So for this odd time complexity is order of 1. So now we'll look into the solution. So if you look into the solution, so I have just explained all. I have explained this pseudo algorithm as well here as well. This one less than power is nothing but 2 to the power, whatever it is. So I have explained why we are taking bit length and how this power works, why we are subtracting from everything. I explained that at the end this will be the very optimal solution. We are just taking the bit count to generate the string. Yeah. So this time complexity will be order of 1. So this time complexity is order of 1. So this time complexity will be log of k, as I told. I hope yeah, this is very easy question, but in depth we should have so much knowledge how this bit works, how come this bit works into manipulating that string. Yeah, I hope you guys understood what I attempted to try or I explained. If something you guys didn't understand or something you wish this could have been explained better, please feel free to add a comment. Thanks for watching.